Hello everyone. This tutorial will show you how to calculate proportional similarity. In other words, pairwise comparisons among two communities. You can actually have more than two communities that you're considering. In the case of our lab, we were considering three of them. But let's start with a simpler example here. These values were taken from the lab handout, where we have 10 species, A through J, two different communities that are considered, and a survey of how many organisms are occurring within each community. So proportional similarity, the formula is actually quite simple, and it is equal to 2w over a plus b. Now the pieces of this formula are, now w is the sum of the lower numbers between communities. So between, say, species A, the lower number here will be, of course, 0, right? And it's the sum of all of them, which I'll show you how to calculate. A is simply the total number within community 1, and B is the total number within community 2. And the range of values, or the output from this formula, will actually be a value between 0 and 1. 0 indicating that there is no similarity between these communities, and 1 would indicate a perfect one-to-one similarity. But of course your values in the real world will be somewhere in between. So let's see how this is done. So if we look at the actual pieces here, which one can we do right away? Well, the sum of the total in each community is really the easiest to do first. So why don't we go ahead and do that? So why don't we put our total down here? So we're all familiar with the function sum, so equals sum. And I'm going to just sum up everything in this column, all of our members in community 1, 240. And since this is a relative cell reference and we're referencing the same number of cells above it, I can actually just copy this formula and paste it right over, and we end up with 180. So what else are we going to need for this formula? So let's just kind of center it, maybe give it a different color just to differentiate it, that these are totals. So we're going to need the minimum among the two lower numbers between communities. So why don't we relabel this column here and call it min. So these will be our minimum values in this column. And there's actually a function called min. And so equals min, and you define a range of values. It could be either a row, a column, it could even be a block of rows and columns. So in this case we want to differentiate among these two communities which one has the smallest value. So I'm going to highlight those two cells, close parentheses, and of course our minimum value is 0. Now since, again, these are relative cell references in this formula, I can just take this formula, copy it, paste it all the way down, and it'll do everything automatically for me. So looking back at our proportional similarity formula here, we're going to need W, the sum of the lower numbers. And here we have all of our lower numbers, so we need to sum that up. So we can actually construct the formula this way. So why don't we just sum that column, sum of all of the lower numbers between all of our, our two communities here. So there you go. So here is the actual formula. Give this a different color perhaps. Alright. So why don't we actually calculate proportional similarity somewhere close by. Maybe here is fine. So here's our formula. So equals. It's going to be 2 times W, right? Which is this. 2 times W, which is in this cell. So I'm going to reference this cell right here like that. And just to be safe, I'm going to enclose this numerator in a set of parentheses, just to tell Excel that this is a numerator and all of these terms will be evaluated in the proper order. So 2W, that's already in there. 2 times the sum of the lower numbers over the sum of 1 plus the sum of 2. Alright, well that's easy enough. So that's going to be equal to sum this range here. We're going to add these two values together. So our proportional similarity then is about 0.36 for these two hypothetical communities. Now what if we wanted to extend this idea into 3 communities? What if we had the same 2 communities that we had from the previous example here, the same values, but we just added another column for a 3rd community? This example more closely approximates what we actually did in the field, where we sampled from a forest edge, a disturbed meadow, and a disturbed wetland. So all we would really do then is make pairwise comparisons. We already did communities 1 and 2. We did that pairwise comparison, and we ended up with about 0.36. So then you would make another pairwise comparison, say C2 to C3, and it's all calculated the same way, with the same kind of procedure and formulas. So the similarity between C2 and C3 is a little bit higher. And finally, we would make a final pairwise comparison between C1 and C3 over here. So that exhausts all of our possibilities, right? And we find an even higher similarity between communities 1 and 3 at 0.57. So that's how you calculate proportional similarity. So in your real example, this is how it's set up for the actual data that we'll get with our invertebrates.